computer. All right, good afternoon again, ladies and gentlemen. So we have a question in front of us. All right, it's a lovely question. All right, don't be afraid. When your teacher says a lovely question, doesn't mean it's inherently evil. Okay, most of the time. Okay, so let's take a look at the question. We have a circle with diameter 10 root 2. That means from S to Q. From S to Q is the length 10 root 2. I say, sorry, that's not true. It says we have a square inscribed in a circle. The square PQRS is drawn inside the circle. The vertices of the square lie on the circumference of the circle. Each length of the square is 10 centimeters, and we want to show that the diameter of the circle is 10 root 2. All right. Okay. Now, if we have a circle, inside a square inside a circle, right? Let's just consider the square by itself. So considering the square by itself, each length is 10 centimeters, and this is also 10 centimeters. We know that these parts here, P, Q, R, and S, touch the circumference. Okay. All right. Where would we find, what would the diagonal represent? What would the diagonal, this diagonal here from S to Q, what would that represent? What does that diagonal represent? That would represent the diameter. Does that make sense? Does it make sense for you? All right. Okay, so it makes sense for it to be the diameter. Now, if that's the diameter, then I can split up this square into 2 triangles, right?
Okay.
I can split up this square into 2 triangles. So we have one triangle, especially 2 right angle triangles. Please forgive my handwriting, right? Where this is 10 centimeters. This is also 10 centimeters. Okay. So if right there's 10 centimeters, let's call this S, R, and the Q, right? If SR is 10 centimeters and RQ is also 10 centimeters, what would be the length of line SQ, which is a diagonal? How would I find it?
Half base times I.
For when I'm finding the area of a triangle, right? How would I find the length of line SQ?
So maybe it would find the area of the square, so then divide it by 2.
Well, yeah, could that work? What would we divide by the area of the square? But let's think about something else. What about Pythagoras theorem? Right, it's a right angle triangle, yeah? What does Pythagoras theorem state?
C squared equal square root A squared plus B squared.
C squared equal to A squared plus B squared says that the square of the hypotenuse is equal to the sum of the square of the other 2 sides. And if we transcribe some more, we can say that the hypotenuse C, okay, the C by itself is equal to the square root of, open bracket, A squared plus B squared, close bracket. Right? Okay. So so SQ would be my hypotenuse. That's my longest side, right? That would be my longest side. Can you see it? Let's stamp. Where is it? Arrow. Oops. Okay. So SQ would be my longest side. Similar to there. Yeah? So what I would need to do now, so since SQ is my longest side, I am going to use Pythagoras theorem to find the length SQ. My other two sides are both measured the same. They're both measured 10. So C is equal to the square root of 10 squared plus 10 squared. Right? 10 squared plus 10 squared is 100, right? So it's 100 plus 100, which is equal to 200. All right. Now, 200 is 10 root 2. So here's the rule. So if I can, the rule is, let me write it in red. The rule is the square root of m times n, right? The square root of m times n is equal to the square root of m multiplied by the square root of n. That's a rule. Okay. Not sure how we can, if anybody had gotten a rule like that, but we can do that rule, right? The square root of m n is the square root of m times the square root of n. We can break down, using that rule, we can therefore break down 200. 200 is equal to what? Well, it's equal to a lot of things, but the easiest one to use would be the square root is equal to 2 times 100. That is 200, yeah? So what does that mean? So think about this rule in red. Think about the rule in red. Am I? Okay, good. Think about the rule in red and how I can break down this 2 times 100. So C is also equal to the square root of 2 multiplied by the square root of 100. That's also true, right?
Yes.
All right. So what is the square root of 2? Well, we don't know. The square root of 2 is equal to the square root of 2, and the square root of 100 is equal to what?
10.
10.
So the length of the diameter is equal to 10 root 2. There we go. So you start using Pythagoras theorem.
So
I
if
thought-
we did it the other way, so again, the C equal square root A squared plus B squared, sir. So wouldn't you still get the same number?
If you get the same number, well, yes, right, but you have to be careful with the formula. You have to be careful with the formula.
Sir,
Mm-hmm.
would you get this? Sorry, you would still get the same answer when you find the square root of 200.
Yes, you get the same answer when you find the square root of 200. But what they remember now, they want us to show that. That means you have to do working out, I guess that's one way you could say that the square root of is equal to the square root of 200. And you can find the square root of 200 and you can find the answer of 10 root 2. And then you'd say that the square root of 200, so root 200 is equal to 10 root 2 when you find the two answers, right? Which is 20, I think it's 20 point something. No, the square root of 200, the square root of 2 is 1 point something. So the square root of 200 would be
14.4.
So I got 14.1.
yeah, and so that's 14.1, and this is also equal to 14.1. So if these two are the same, so it says since the square root of 200 is equal to
So
14.1, and the square root of 14.1 is equal to 10 root 2, then the square root of 200 is equal to 10 root 2. You can say that. That can be said.
sir, why not put it to 2 decimal place? 14.14.
There's you can put it to 2 decimal places. I would round it up to 3 decimal places. That's my personal preference. Right? Round it off at 3 decimal places. That's my personal preference. But if you can show this rule here in red, if you can show them that you know this rule here in red, it will work wonders for you. Okay, so that part's okay. Did I lose anybody? I know there's some persons who came late, so let me just go through it. Let me just go through that. So we are saying that, well, the question is asking us to show that the diameter, whoops. Right, the question is asking us to show that the diameter of the circle is 10 root 2. All right, and when we look at the square, all right, we have a diagonal. They put everything in the diagram is a visual clue, right? They would not have put the line SQ there if it wasn't a clue. Okay. So we have PQR, we have the line SQ. That means I can break down the square into 2 right angle triangles. Here's my right angle triangle on this side. I hope you're seeing the mouse. There's an arrow pointed to it, right? And since I have a right angle triangle, I can find the length of the hypotenuse using Pythagoras theorem. So using Pythagoras theorem that says that c squared, or the length of the hypotenuse, is equal to the sum of the square of the other 2 sides, i.e., that is c squared equal to a squared plus b squared, right? That's Pythagoras theorem. So we use that, solve for c, and we see that c is the square root of 200, and the square root of 200 is also equal to 10 root 2. Because those two are equal, then square root of 200 must be equal to 10 root 2. The diameter is 10 root 2 centimeters. All right. So from there, we can also calculate the area of the circle because we know the diameter. All right. I mean, should I continue there, or you're good up to there? Everybody's good up to there? Should I continue answering the rest of the questions?
Sir. So basically, we're going to
Yes, sir.
it's just the hypotenuse.
Uh-huh. So basically, the first trick is to find the length of the hypotenuse and know that the length of the hypotenuse is equal to the diameter. All right, not the radius, the diameter.
Okay,
Okay. And then we can calculate the area of the square. I don't see where they ask us to use the I don't see where they're asking us to use pi, what we're supposed to use pi as. I don't know if pi is 3.14 or if pi is 22/7. Not sure. I personally prefer the 22/7. I prefer that pi is 22/7. I like fractions better than I like decimals. So I would use that instead. So we can find the area of the square. Let me just clear these drawings. Okay. Let's find the area of the square. We know that area of a circle. Area of circle, let's put a little circle down here, so is equal to pi r
square.
Excellent. So what is r equal to?
14.14.
Wouldn't it be 7? 30 was 40.
Is equal to the diameter divided by 2. What is the diameter?
The diameter was 14.14 and the radius would be 7.07.
Okay, yes. All right. Or 10 root 2. Right. I know you guys love decimals. That's what your calculator gives you. Right. But we can do this without the calculator too. All right. So this is equal to 10 root 2 divided by 2. The radius is equal to 5 root 2. Does that make sense?
Yes, sir.
All right. God, they said they even gave us the diameter equal to 10 root 2. Okay. All right. So again, so we know that area of the circle is equal to pi, which is, I'm going to say 22/7, multiplied by 5 root 2, and we're going to square that. Right? Now, similar to how the square root of mn, similar to how the square root of mn is equal to the square root of m multiplied by the square root of n, mn all squared is equal to m squared times n squared. Right? Which means, I'm doing this without calculator, which means that the area of the circle is equal to 22/7 multiplied by 5 squared times square root of 2 squared. Okay, so what is so help me out here. So we have, this is 22/7. 5 squared is equal to
25.
25. And the square root of 2 squared is equal to
2.
is equal to 2, right? Because the square root and the square root cancels out square. Square root cancels out square. Okay. So area of circle is equal to 22 times 50 divided by 7.
There, I got 157.14.
Okay. That's so, yeah. 157
1, 4.
okay, 14 centimeters squared. All right, and we're done. 2 marks in the bag. All right. Similarly, so we can, but area of square is supposed to be very, very easy.
Sir, then I want to know if I missed something. When did we find the hypotenuse?
I'm sorry, I didn't hear that one. Go ahead.
When did we find the hypotenuse?
When
Yes, sir, because I think I missed something.
the line SQ, that line SQ is also equal to the hypotenuse.
Okay, sir. What was the hypotenuse?
Sorry, go ahead.
And I'm asking what was the hypotenuse?
The length of the hypotenuse is equal to 10 root 2, or the square root of 200.
Oh,
That's equal to the square root of 200, or which is also equal to 10 root 2.
okay, sir. We got the and we use the pi by, so oh, you multiply by pi by the okay, I see what's going on. But sir, why did we have to multiply it by pi though?
Area, because area of circle is equal to pi r squared. You want to know how they derived the formula? You want to know how they arrived at the formula pi r squared?
No, sir. I'm not. I'm because I thought you could have just used the Pythagoras theorem alone to get the diameter.
Oh yes, you use Pythagoras theorem to get the diameter alone. But then I moved on to part B1 to be more specific, which asks us to calculate the area of the circle.
Oh, I see what's happening. All right, sir.
And from part B1, we could even say, hey, we can calculate part B2 as well, which is the area of the square.
Okay, the area of the square would be what, 10 times 10 squared.
Right. Area of a square is equal to the length
Squared.
The length squared. Is equal to 10 centimeters all squared, which is equal to which is 100 centimeters squared. Okay, good. So that's the area of the square. How do you think we can find, or how do you think we will find the area of the shaded region? What do you think we should do?
So I think you should minus the circle, the area of the circle from the area of the square.
All right, that's a good step.
All right, sir. Let's see. As what she said, minus the area of the squared from the area of the circle. But I think we should also multiply it by what? A quarter?
Multiply it by a quarter, or in other words, divide it by 4. Yes.
Yes, sir. Is that it?
That's correct.
Okay.
All right. Do you see, does anybody see?
Sir,
Yes.
I don't know how you end up at that. I don't know why you should take away the area of circle from area of square.
Okay,
And by 4.
no problem. May I clear the drawing?
Yes, sir.
All right, let me clear all these drawings here. And let me draw my own circle. That's circular, okay. And inside my circle, I'm going to draw and it's supposed to be a square. Hey, that's kind of good. All right, I surprised myself. Okay, so that's a circle and the square that we are looking at. Okay, let us fill this with color. I can't fill it with color, but let me try something anyway. First, let's change the color to something like yellow, and then that. Okay. So we're gonna fill this with color. Okay, so that's our square that we have filled with color. Okay, how many sectors do we have? How many segments do we have? We have this segment over here, and we have this, we have a shaded region right here. Sorry, we have the area of the square and we have the area of the circle. So the area of the circle is 157, something like that. Was that it? Area of circle equal to 157.14 or 0.41. I'm not sure. And then we said the area of the square is, sorry, area of square.
Yes, sir.
Okay, is equal to 100 centimeters squared. Okay, so if I subtract the area of the square from the area of the circle, I will only be left with, these areas. I'll only be left with these areas, right? These orange areas, okay. Now remember, it's a circle and a square, so we expect that these areas will be equal. But they don't want the entire orange area, they only want a portion of it. What portion of the orange area are they asking us to find?
The shaded portion.
That shaded portion, okay. Right? And that shaded portion, is that shaded portion the entire orange area?
No, sir, only one side.
Only one side of it. More specifically, if I were to express that side as a fraction, what fraction of it are they asking us to find?
1/4.
A quarter.
1/4 of it. Okay. And that's so we subtract the area of the square from the area of the circle so that we can get the whatever is left. So we can understand whatever is left. And then we divide that by 4, we divide it by 4 or multiply it by a quarter in order to get the area of the shaded region. So let's do all that. So area of circle minus area of square divided by 4. And that's 157.14 minus 100. Divide that by 4, that is 57.14 over 4 which is equal to the area of the shaded region is 28 something, 14 point.
14.285.
14.285 centimeters squared. All right.
Sir,
Yes, ma'am.
what if they said that you should run it off to 1 or 2 decimal place? Would it be 14.3?
14.1, one decimal place will give me 14.3. Yes. Correct to one decimal place, 14.3. All right. Oh, I see something in the chat. All right. Hi. Okay. Yeah. Right. So that's how that is done. How? So what we want to consider is that these shapes are not static. You know, can use and by static I mean they're not stuck in one place. Okay, can use our imagination. We can color, we can shade them, color and shade them in the exam if it will help you to understand what the question is asking. Okay, I have a circle. My circle is 157.14 centimeters squared. That's the area. I take a square and put it over my circle. All right. Do I have any portions left out? Yes. These orange portions are left out. Yeah. Then from there, what can I do with these orange portions? They only ask me to find the area of one shaded region. So that means I'm gonna subtract, then divide the total area by 4. All right. Plus they only ask for a quarter of it. Okay. All right. SOS. Is that it?
Yes, sir.
All right. Anybody else have any questions? No? We all good? Excellent. Excellent. Welcome, Carlene.
Yes, good night, sir.
Go ahead.
What were you saying?
I'm saying go ahead. I was wondering if anybody else has any questions.
Oh, no, man.
All right. All right. Bam, bam, bam. Some of the things that we have done. We have a couple minutes left. Oh, I should apologize. Last time, what happened was that the internet, not the internet. The computer battery just died suddenly. I thought it was on charge. It was charging, but it died suddenly. I got it. I got someone to look at it. It's fine now. So I really do apologize for Monday. It seems as if I just ran away, left you. I didn't, promise you. Okay. All right. We were looking at number 8. I know that nobody's not seeing anything right now. Just a second. We're looking at number 8. Okay. Can everyone see?
Yes, sir.
Yes, sir.
All right. So says that Marla buys 2 types of mobile phones, a B Flow and a C Flex. Sounds familiar. One B Flow mobile costs $6 and one C Flex costs $80. She buys X number of B Flow phones and Y number of C Flex phones, but she must not spend more than $1,200. All right. So I would actually, okay. So one B Flow phone costs $60, right? Therefore, X number of B Flow phones, that's X times $60, or 60 times X dollars of B Flow phones plus $80 of Y Flex phones. When I add up all of that, I'm not supposed to get more than 1,200. In fact, I used the wrong inequality sign there. I'm supposed to get less than or equal to $1,200. Does that make sense as I was writing it, or does it look like some kind of strange language?
It makes sense, sir.
It makes sense, sir.
All right. Good. And that's the inequality that they're asking us to represent. Okay. I have $60 for one B Flow phone. So 60 times X will tell me how many B Flow phones I bought. I have $80 for Y Flex phone. So 80 times Y will give me the number of C Flex phones there. When I add the two together, I'm not supposed to get more than 1,200. All right. The number of B Flow phones must be greater than or equal to the number of C Flex phones. Write down an inequality in X and Y to show that. Is there anybody who wants to tell me what to write? Let's highlight some things though. It says what it said. It said that the number of B Flow phones must be greater than or equal to. So we can actually answer it from right here. Number of B Flow phones is X. What is greater than or equal to? Greater than, right? The mouth opens to the greater than section. So this says X is greater than. I'll put a line under it now. Means greater than or equal to. X must be greater than or equal to Y. See there? They actually gave us the answer in the question. Right? All right. So far, so good. Is anybody lost? Don't be afraid to say you're lost, you know. That's why I'm here. If you're lost, it's my job to come find you. All right.
Excuse me, sir. So that would be the equation.
Yes, that would be the inequality. Yeah.
Okay, sir.
All right. Now, mind you, even though they're not telling you this, I'm pretty sure that it's going to come out and look like a graph. right? Let's quickly write that in blue. What is the formula? What's the formula, the general equation for a line graph? What is the general equation for a line graph?
Then I think it is x plus. I think it's x plus x divided by y plus y. Something like that, sir.
X plus? No, I'm not sure that. I'm not
Plus
sure that's
x squared.
no. All right, go. Y is equal to
mx plus c.
mx plus c. All right, so that's the general. This is the general form equation for all line equations. Y equal to mx plus c, where m is the gradient. M is our gradient. And c is the y-intercept. Y-intercept. Okay. All right. So this is that's the general equation for all lines. All right. All right. So I'm pretty sure that somewhere, somehow, we are going to have to use this, or we have to make one of our inequalities look like this. Okay. All right. Let's scroll down. So it's very good to keep in mind. I shouldn't do that, and let me undo that. Pretty sure I'm going to need something. All right, let me take this part first. Let's move it over here. And then let us also take this part here and move it over here. Pretty sure we're going to be using them again. All right, let's move on. Aha. It says represent the two inequalities on the grid shown below. Label as R the region that satisfies both inequalities. All right. It also says what is the total number of phones represented by, oh, sorry, the total number of phones is represented by X plus Y. According to the graph, what is the largest possible value of X plus Y? Okay. So it doesn't ask us this directly. It doesn't ask us to convert to the gradient y equal to mx plus c, the line form, directly, but we must do it. Sorry, we must convert to y equal to mx plus c. So let's take this. Let's take this one. Oops. So let's take this one and convert it into the form y equal to mx plus c, which first means we need to solve for y. Right? First means we need to solve for y. So this is the same thing as saying that 80y. So 80y is less than or equal to
Negative
1,200, right? Minus 60x. Now, all of these numbers here are divisible by 10. Can't I just divide? Let's just divide everything through by 10. You know what? Let's not do that. Let's solve it properly. Yeah, let's solve it properly. Which also implies that y is equal to 1200 minus 60x divided by 80. Let's solve it properly. All right, we're almost in the form y equal to mx plus c. Since I have the two numerators, and those two numerators have a common denominator, all right? I have two numerators with a common denominator. I see that. So just like so, if I have a plus b and both of them are divided by c, that's the same thing as saying a over c plus b over c, right? Does that make sense?
Yes, sir.
Right? And we can only do this. We can only do this when the numerators have a common denominator. It's the same denominator. That's the only time I can split them up. Can't split them up any other time. Okay? Let me show you in yellow. If I have a over b plus c, I cannot say that this is a over b plus a over c. That would be wrong for me to say. Can't say that. Okay? I can't split them up. They don't have the same denominator. I can only split them up if it's a single denominator below both of them. That means, so this means that y is also the same thing as 1200 over 80 minus 60x over 80. And I can divide that. Can't I? I hope so.
Excuse me, sir, I have a question.
Yeah.
Yeah, on the other side, sir, how did I get 80y to equal 100 and 1200 minus 60?
Oh, I have equal, right? It's supposed to be less than or equal to. Thank you very much. I changed my inequality without even knowing. My apologies. Thank you.
So, sir, why would it be cos like 1200 minus cos of x? What would you cos it, sir?
Cos of x. That's not cos. It's supposed to be 60.
Oh, because I was confused.
It's at 60. It's not cos, you know, it's just that see, my handwriting is so beautiful. You understand?
Yes,
I
sir.
can't
Sir,
understand
I
it.
was asking, sir, why did you rearrange it, sir?
Oh, we rearranged it
understand.
so that we could get it into the form y equal to mx plus c. Let me change this color. Maybe will yellow work? Oh, it doesn't work like that. Okay, so I was trying to get we're trying to get it in this form over here. Y equal to mx plus c. That's why we rearrange it. Because if we know the gradient and the y-intercept, we can draw the line. If we know the gradient and the y-intercept, we can actually draw this line on the grid, which is what they want. They want us to draw this line on the grid. Yeah?
I don't understand.
All right, let me go back. Just a second. Let's go back a quick sec. See the question here. Question says represent just part 3 up here. It says represent the two inequalities on the grid shown below and label as R the region that satisfies both inequalities. Now, anytime you have a grid, that means graph, don't it? If you have a grid,
Yes,
that means
sir.
graph. So that means we have to go either draw a line or draw a curve. Yeah? I'm either drawing a line or I'm drawing a curve. Now, which line are you going to draw that says 60x plus 80y less than 1,200, less than or equal to 1,200? Can you see that line there? Or is it better
No,
for us
sir.
to put it in the form, or is it better for us to put it in the form y equal to mx plus c, so that we can know where the y-intercept is and where the gradient is? I put it to you, my friend, that it is better to put it in the form y equal to mx plus c, so that we can see where the gradient is. All right, let me just finish up real quick. All right, 1,000. Let me finish up real quick and I can show you. 1,280, 1,200 divided by 80, that is what? 120 divided by 8. How much is that equal to? That's what, 30?
15.
15.
What? What was that?
15.
Sir, 15.
15?
Yes, sir.
Okay, 15. Okay. Minus 60 over 80. Minus 60x over 80. Zeros cancel. That's the same thing as saying 3 over 4. So it's minus 0.7. Actually, I prefer the fraction, you know. But you understand decimals better. 0.75x. Okay. Now, this is in the form y equal to mx plus c. Here I have my y. Where is m? What is m?
15.
Remember, is m and x are right beside each other.
There's a
Sir,
M
Zero
would be
point seven five.
1,200.
The negative, right? The negative 0.75. And this one would be c. So the equation is y equal to negative 0.75x plus 15. Okay. All right. I'm going to borrow some help. I'm going to borrow some help in the interest of time. I'm going to borrow some help from Desmos.com. All right. Desmos has a graphing calculator, which is why you're not allowed to bring phones. One of the reasons why you're not allowed to bring phones into the exam. All right. I'm gonna show you on Desmos. Okay. In the interest of time. Okay, so we had said that the equation was y is equal to negative 0.75x plus 15. Okay, that's what it has said. Let's zoom out a little bit so that we can see the graph. So that's the graph there. Okay. It has another equal, oh, sorry, I used the wrong sign. Didn't I use the wrong sign here? The sign should be, it's not less than or equal to. It should be less than or equal to, right? So that's what the graph will look like. And the shaded region is the part that is less than or equal to the equation here. Right? So we can use any value here. Okay. We can use any value that is below the line. That's why we say less than or equal to. What's the next inequality? The next inequality said that the number of phones next inequality says that the number of phones, number of B flow phones must be greater than C flex phones. That means that X must be greater than Y. So let's put that in. X is greater than or equal, sorry, let me just confirm. Yes, X is greater than or equal to Y. And there we have another line, right? That shows us the inequality. Okay, so the blue line or the blue region is X greater than or equal to Y. Okay. Now, what's the greatest number of phones I can buy? I can buy, well, I can't buy 8.5. You see an 8.5 there? I can't buy 8.5 B flex phones. And I can't buy 8.5. Sorry, I can't buy 8.5 B flow phones, and I can't buy 8.5 C flex phones. So the answer is I must buy 9. I must buy 9 B flow phones, right? And 7 C flex phones. Oh, or is it 9 and 8? And 8.5 plus 8.5, that's 17. So it's 9 plus 8. Sorry. So I must buy 9. So the answer is I must buy 9 B flow phones and 8 C flex phones in order to satisfy the inequality. Right? Okay. Let's quickly try to do that on. Let's quickly try to do that on this graph here. Well, I can't do it on this graph, but the graph doesn't have enough space. What I can tell you, what I can show you, let me zoom out a little bit. It's going to be difficult for us to see a bit. All right, but what I can show you is that I need from the formula y is less than or equal to negative 0.75x plus 15. I'm going to take the constant. Remember that c is equal to the y-intercept. Remember that. And our y-intercept is 15. So that means that I have a point right there. That's one of the points. Okay. So when x is equal to 0, y is equal to 15. Okay. I also need to find out. So from there, I need to draw a line. Let me see. Let me take a point. Let's say, I don't know. Let us say that what so we say to complete this line, sorry, to draw a line, I need 2 points. So we say let x be equal to 0. Let x be equal to 0 in the equation. Then y is less than or equal to negative 0.75 times 0 plus 15. So y must be less than or equal to 15. That's why I get y is equal to 15. Okay. We can also say let y be equal to 0. And the reason why we just really need 2 points. Doesn't matter. Y could have been any other number. It could have been 3, 4. I'm just saying use 0. Okay. So let y equal to 0. Then 0 is less than or equal to negative 0.75 plus 15, and then 7.5x. Sorry, let me erase that and do it properly. 75x plus 15, and then we solve for x. Solve for x. We would get that x is equal to negative 15 over negative 0.75. Quick working out, that would be what? 15 over 0.75, that is also 15 times 4 over 3, which is equal to 20, right? So x is equal, so at y equal to 0, x is equal to 20. Yeah, which is somewhere, I'm not sure. I can't see the lower end of this let me try to see the lower end really quickly. Okay, it's right there. So y equal to 15, x equal to 20, and I'll just draw a line to draw a line. And this would be the line. This is the line y equal to, sorry, less than or equal to 0.75 plus 15. Negative 0.75 plus 15. Okay. The next inequality is y is less than or equal to x. Right? Y is less than or equal to x, which basically means if y is 0, x is 0. If y is 5, x is 5. So I'm just going to draw a straight line. Ouch, can you see that? 5 and 5. 10 and 10, 15 and 15. So any value that y is, x is. That's what it means, and it says x is equal to y. All right. The point where both, and we can highlight the point where both lines cross each other. And that part will be the answer to the equation. And this shaded region here in orange, this, probably not orange, but this shaded region here would satisfy the inequality. Right? That part would satisfy the inequality. All right, so let me clear that. So let's just leave it there for today, right? And see where this takes us next week.
Yes, sir.
All right. Please ask about the recordings. Please ask about the recordings. You get them to look at. You can go through them in your own time and help to increase your own understanding. All right.
All right, sir.
Okay.
All right. Have a good one. Take care.
Bye.
Bye bye.